Now that we have a good understanding of a sorting algorithm like selection sort, we can continue on and learn additional sorting algorithms. In this lecture, we are going to begin looking at what bubble sort is. And bubble sort is one of the simplest sorting algorithms because it just repeatedly swaps the adjacent values if they are in the wrong order. So it's not going to be super performant for large data sets, but it's still a good sorting algorithm that we can evaluate and learn. So we'll create ourselves an array here, and we'll give it 5, 4, 1, 3, and 2. And remember, what we're going to do is sort adjacent values if they are in the wrong order. So we see here, so we'll start at 5, index 0, and we see that our adjacent value is 4, so now we can swap 5 and 4 and then leave the rest of them the same. And we're still on value 5 because we have not iterated through the entire array. So now we're still at 5, and we're going to swap now with value 1 because 1 is less than 5. So now our array is 4, 1, 5, 3, 2. And again, since we haven't completely iterated through the array yet, we are still on value 5. So now we will compare 5 and 3. 3 is less than 5, so now we will swap 3 and 5. So now we have 4, 1, 3, 5, 2. And now that we're almost at the end of the array, we have one more check that we need to do, and we need to check if 5 is less than 2, which it is. So now we have 4, 1, 3, 2, and 5. So now we have completely iterated 5 through the array. So now we know that index 5 is in the correct spot. 5 is in correct spot. So now we're going to go back and we're going to start over with 4. So now we're here at 4 and we're going to compare it to 1. So we know that 1 is less than 4. So now we go 1, 4, 3, 2, and 5. We're still at 4. So now we compare 4 and 3. So we have 1, 3, 4, 2, 5. So you're starting to see why this algorithm might not be the most efficient one of all the sorting algorithms that we will learn. So we're still at 4. So 4 is less than 2. So 1, 3, 2, 4, 5. We know that 5 is in the correct order already. So now we're done with 4. So now you're quickly starting to see the pattern here. So our next value is 1. We compare 1 to 3, 2, 4, and 5. So now we know that 1 is in the correct spot. So now we compare 3 and 2. So we know that we need to go 1, 2, 3, 4, and 5. And now we have our sorted array. So we are now done with sorting this array. So again, now you can see why it is not the most efficient algorithm. But let's look at some pseudocode to see what it would look like. Oop, not a B. So we want some pseudocode. That way we can have a blueprint for what we want to code when we go to do our implementation. So we know that we started at iteration 1, so this would be one for loop. So we'll say for I in 0 to size -1, and then we're comparing it with all the elements adjacent to it. So we're going to need another for loop, so we'll say for j in 1 to size minus 2, and then we will do our compare j to I, compare j if it is greater than j plus 1, and if it is, then we want to swap j and j plus 1. And that is basically our pseudocode for this. So let's do one more example. That way we make sure that we have a good understanding of how this algorithm works, now that we kind of know what the pseudocode is. So we will do an array of values of 5, 1, 4, 2, and 8. So this is our unsorted vector of values. So we will start here, and then this will be our I plus 1. So now we compare. We see that we need to do a swap, 4, 2, and 8. So we're still here at 5. Compare. We need to do a swap. Now we're 1, 4, 5, 2, and 8. So we're here still. Compare. 1, 4, 2, 5, 8. And now we know that 5 is in the correct spot because our next comparison will not yield a swap. So now we also know 1 is in the correct spot. So now we need to start here, and we will evaluate 2 and 4, and we see 1, 2, 4, 5, and 8. So that was a very simple one, and we were able to quickly see how this works. It works really well with arrays that are already kind of sorted, because as you can see, we had way less iterations needed here than we did in our array up here. So now that we have a really good understanding of how bubble sort works, let's go ahead and begin implementing this algorithm in the next lecture.